Hello and welcome to this IB Maths Intense session, our video number 4 on the topic of exponentials and logarithms. And in this video we'll be having a nice gentle introduction to the world of logarithms. This is a key concept for everybody, standard level and higher level. There it is on the syllabus guide. You can see laws of logarithms, change of base of a logarithm, solving exponential equations using logarithms, and introductions to logarithms with base 10 and e. So it's important that we really understand what logarithms are before we go any further. So in the previous videos we were looking at the world of exponentials, and we're very used to an expression of the form a to the x equals b. And we know that we can rearrange that so that if we wanted to know what a is, then we can just simply rewrite that. Hopefully you will recognise that a is b to the power of, 1 over x. So if we had a squared equals b, a would be the square root of b, so b to the power of a half. Or a equals the root of b in this case would be another way of writing the same thing. So we can manipulate the expression a to the x equals b so that we can get an expression for a. But what if we wanted to change this and get an expression for x? Now, this is where logs come in. Now, in the initial expression, we had a base of a to the x equals b. And we referred to a as the base and x as the exponent. Well, when we want to find the value of the exponent, x, we have to take a log to base a. This is the same base that we had before, of b. In other words, we're saying, what did I have to raise a to the power of to get b? Well, the answer was x, because a to the x equals b. So this is called the base of the log a, and it's basically an expression that says log a to the power log a to the b. What did I raise a to the power of to get b? So, for example, if I had log to base 3 of 8, log to base 2 of 8, let's just correct that for you, log to base 2 of 8, I'm asking the question, what did I have to raise 2 to the power of to get 8? Well, we know that 2 to the power of 3 equals 8, so log to base 2 of 8 must be equal to 3. Log to base 5 of 25 must be equal to 2, because 5 squared is 25. And a little bit more complicated, but not really, log to base 4 of 2 must be equal to a half, because 4 to the power of half, or the square root of 4, is 2. So try and get that fixed in your mind, what it is that we're working out when we're working out the log. Log to base 2 of 8, the first example there, is saying, what do you raise 2 to the power of to get an answer of 8? And the answer is 3. Very good. Just a few special results to show you with that. So if we know that b equals a to the x, and x is log to base a of b, that's just manipulating that. Well, here's a couple of things just to simplify, or to be able to recognize. If I took log to base a of a to the power of x, then by definition I'm asking, what do you raise a to the power of to get a to the power of x? Well, the answer must be x, because I've raised a to the power of x. So there's something to remember. If you see something in the form log to base a of a to the power of something, then the answer must be whatever that power is. Similarly, if I just rewrite what we've got here, I'm going to just change the variables a bit. We're going to say b equals log to base a of x. In other words, a to the power of b equals x. So if I was to raise a to the power of b, but written in that form, a to the power of log a of x, well, that must be also equal to x. So we've got two new expressions there. Log to base a of a to the x equals x, and a to the log a of x is also equal to x. Worth recognising those. You might see those in a question. A couple of other things to point out to you. Firstly, you will often see log x just written like this without a base. Well, this is our shorthand for log to base 10 of x. So if you see no base and the word log, it means it's to base 10. And you might also see ln of x written down. This is a special base. This is log to base e, the exponential function or number, and ln is shorthand for log to base e. So you'll see those interchangeably in different questions with logs. And one other thing about what are permitted values, if we've got b equals a to the x, and if we're saying that a must be positive, then the result, b equals a to the x, must also be positive, because when you raise a positive number to any power, whether it's positive or negative, it will give a positive result. So if I have log to base a of b, then a is positive means b must also be positive. In other words, it's not possible to take the log to base a of a negative number. That b will always be positive. So bear that in mind. Now, a few little bits and pieces that we can do with simple logarithms, just evaluating them. Here's a few just to make sure your head's in the game. Remember what we said before, log to base 3 of 27. I should be able to work that out now without a calculator. This is saying 3 to the power of something was equal to 27. That's what log to base 3 of 27 means. What did I raise 3 to the power of to get 27? Well, hopefully you can remember that 3 to the power of 3 is 27. So log to base 3 of 27 must be 3. This one, second one, 10 to the power of something equals 1. Well, hopefully you can remember anything raised to the power of 0 gives an answer of 1. So log to base 10 of 1 is equal to 0. The next one, 3 to the power of something, 3 to the power of x, gave a third. Well, hopefully you remember that that needs to be minus 1, because 3 to the power of minus 1 gives us 1 over 3. And d, 7 to the power of something is equal to, well, root 7 is 7 to the half, written in index form, so x must be equal to a half. And then last but not least, 4 to the power of something is equal to 0.5. I'm going to write that as a half because it just is easier to see. Well, we know that a half is equal to 1 over the square root of 4, and 1 over the square root of 4 is the same as 4 to the power of minus a half. So log to base 4 of 0.5 must be negative a half. Again, it's just recognising from the work we did before about exponents what's going on. 4 to the power of minus half is itself a half. We can also simplify expressions with logs, and I think the key thing here to remember when you see something like 5 log x minus 3 log x, don't panic. Log x is just a number. We could call it a. And so that first question, 5 log x minus 3 log x, well, 5a minus 3a would just give us 2 log x. Nothing to panic about. And similarly, if we're expanding out with brackets, we can multiply expressions with logs in the same as we can multiply with a variable a or b. So here we would just get log x times log y, which we can write as log x log y. Just multiply out the brackets here. Minus 3 log x plus 2 log y minus 6. Nothing to complicate this. Don't try and make log x times log y into log xy. Keep them separate, they're two separate numbers. I can square things. Just be careful when you're squaring to keep the whole thing together. Log x plus 5 all squared. Well, first of all, log x times log x is not log x squared. It's in brackets log x squared, because it's the whole thing squared. And I'm going to have plus 5 log x plus another 5 log x plus 25. And hopefully you can see that we could simplify that to make it log x all squared plus 10 log x plus 25. In this fourth example, D, I've got a fraction. What I can do here is split this into 2 to make simplifying possible. I can make that equal to log x over log x log y plus log y. over log x log y. And then I can easily simplify. The first one I can simplify by cancelling out the log x's to get 1 over log y. And same sort of idea. The second one, cancel out the log y's. I get 1 over log x. Nice technique. Split if you can keep the denominator the same, but you can split the top into its two components to make two separate fractions. And then the fifth one, I've just put that in there to see if you spotted that there's a difference of two squares from your algebra work. Log x all squared minus 1. If we remember from our algebra work, a squared minus 1 is a difference of two squares and can be factorised as a minus 1 times a plus 1. So we can do the same, just because it's logs doesn't make it perform any differently. So I would get on the top here log x minus 1 times log x plus 1, and then on the bottom I've got, well, log x plus 1. So very nicely I can cancel those down and get a result simplified there of log x all minus 1. Be careful, it's log x and then is subtracting 1. It's not the log of x minus 1. We'd have to put that in brackets if that was the case. And we can change the subject of a formula with logs. So here we want to create expressions for x in all cases. So let's just write down what we know. Well, we know that if log to base 5 of x equals 2y, 5 to the power of 2y must equal x. And that's another way of rearranging or changing the subject. Here, similarly, x equals, it must equal the base a to the power of 3 minus y, because we're saying log to base a of x equals 3 minus y. What did I raise a to the power of to get x? I raised it to the power of 3 minus y. In the third question, slightly different this time, we know that x squared equals 2y. I raised x to the power of 2 to get 2y. So my result for x, it must be equal to the square root of 2y. And last but not least, I know that 2x all cubed must equal y. Now if I expand that out, I get 8x cubed equals y. So x cubed must equal 1/8 y, and that means x must equal, well, the cube root of 1/8 is a half, and then we can just put the cube root of y there for good measure. Okay, so we can change the subject of the formula quite nicely there. Last but not least, you'll be expected to solve equations with logarithms using the similar sort of mechanism as before with changing subject, etc. In this case, we want an expression for x. X must equal, well, what did I raise 2 to the power of to get x? Well, I raised it to the power of 10, so x must equal 2 to the 10, which off the top of my head is 1024. That's nice and easy. The second example, a little bit more difficult, I guess, but I'm going to write what I know. I know that 5 to the power of 6x had to be equal to 125. I should hopefully recognise, oh, for 5 to the power of 3 is 125, so 6x must equal 3. That means x equals a half. Next one, x to the power of a half must equal 4. So in other words, 4 is the square root of x. Root x is 4, so x must equal 4 squared, which is 16. We can have a more complicated algebraic expression in the logarithm. So here we know that 8x minus 3 must equal 10 to the power of 2, because I'm asking log to base 10. So 10 squared equals 8x minus 3. 8x minus 3 equals 100. That means 8x equals 103. That means x is 103 over 8. And I don't think we can simplify that fraction, so we'll leave it like that. And then last but not least, I've got log to base 5 of x all squared equals 4. So we need to be careful here, because when we take the square root, we'll end up with an expression log to base 5 of x equals, well, remember the square root of 4 can be plus or minus 2. And that means x must be equal to either 5 to the power of 2 or x must be equal to 5 to the power of minus 2. Two solutions here. Be careful with that. Occurs quite a lot with logs. There'll be two solutions. That means x is either equal to 25 or it's equal to 1 over 25, which is 5 to the minus 2. So we've done lots of examples there. We whistled through, just giving you an introduction to how logs work. Hope that was clear. Hope you found that useful. Thank you for watching. Don't forget to like the video, subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. Drop me an email on ibmathsintense@gmail.com if you've got any questions, suggestions, or you spotted any errors. And come back for more when we'll introduce you to the laws of logs and more complicated expressions with logs in the next video. So you take care and enjoy your maths.